Okay, so welcome everyone to our presentation today on the government grants and feasibility studies available in Canada to support the Net Zero initiative. This presentation is being conducted for the Curling Canada Association, and my name is Jonathan Burney with Simcoe Refrigeration. To start off, we're just going to talk about some of the targets which the government of Canada has laid out for us. Back in June of last year, they created the Canadian Net Zero Emissions Accountability Act, and the targets of this act are to reduce emissions by 50% by 2030. So that's the GHG production of our facilities by 50%. The next target was to reduce our carbon footprint by 80% by the year 2050. So these are targets that the government of Canada has committed to, and in response to setting these targets, they have made available grants to support these initiatives in our community buildings. So what does it mean to achieve net zero? If you were to Google search that, what you would find is this definition. Achieving net zero means our economy emits no greenhouse gas emissions, or that we offset these emissions through environmental efforts or carbon capture. So when we're talking about these recreational facilities, really what we're talking about doing is reducing the amount of fossil fuels that we consume at the facility, thereby reducing the amount of greenhouse gases that we emit into the atmosphere, and also making the plants or the facilities as efficient as possible, so further reducing their impact on the environment. We can put this into three pillars of how we can approach this challenge. And starting off at the bottom here, the first thing we want to do is we want to use the cleanest energy sources available to us. So that can take on a few different shapes here. If you are fortunate enough to live in a province where you have access to clean electricity, generally produced through hydroelectric or perhaps nuclear sources, that would be one step in that process. Beyond that, we would want to look at other options like solar and hydroelectric generation to harness that clean source of energy. The next step is to optimize the energy consumption of the facility. We want to make the system as efficient as possible, use as little energy as possible, regardless, if it's a clean energy or if it's a fossil fuel energy. We just want to be as efficient as possible. When we're talking about an ice rink or a curling club, we have this refrigeration system, which is taking heat out of the ice and generally rejecting that heat into the atmosphere. So the other very important component here is we need to look at ways of recovering that waste heat. We want to take that waste heat and we want to recycle it back into the building, and by doing that, reducing the amount of energy that we then need to purchase and consume in that facility. And the last important step here is to eliminate refrigerant emissions. I think we've all seen the news. They've talked about ozone depletion and now global warming over time, and there's many factors that play here, but certain refrigerants contribute to that. So what we want to do is we want to promote the use of natural refrigerants which have no ozone depletion and no global warming potential should they be accidentally released into the atmosphere. So some of those refrigerants would be your ammonia, your CO2, propane is a new refrigerant being looked at for that application. So that is the third column, using or reducing our refrigerant emissions, which impact our global warming and ozone depletion. What I will do is I'll start off reviewing one of the grants that are currently available. This grant is the Community Building Retrofit Fund. As the name suggests, this is intended to be used for retrofit applications. The objectives of this grant are directly in line with the mandates set out by our government. So they want to see a 50% greenhouse gas reduction within 10 years, and then they're looking to see an 80% greenhouse gas emission reduction in 20 years. They also stipulate that they'd like to see lowering operating costs of facilities, creating new local jobs, and providing better building quality and greater community use for the general public. So who's eligible for this grant? So to start off, certain large cities in the country are not eligible because they have access to other sorts of funding. So the large cities which are not eligible for this would be Vancouver, Edmonton, Calgary, Toronto, Ottawa, Montreal, and the Halifax Regional Municipality. Beyond that, all communities in Canada should be eligible for this fund. And the type of facilities, they should be municipally owned facilities or non-for-profit organizations, existing in these communities. And the type of buildings which they would like to see apply for these grant funds is their athletic facilities such as indoor ice rinks, sporting arenas, swimming pools, gymnasiums. They also mention recreational facilities and clubhouses, cultural facilities, art galleries, auditoriums, and libraries. And then they also list senior centers, clubhouses, and halls. So certainly hurling clubs would fall under the applicable buildings for this grant. So this grant has a few different streams in which you can seek funding. I'll just review those here briefly. So the first one is this monitoring and analysis opportunity. So in this case, the grant will pay for up to 80% of eligible costs to a limit of $25,000. And the intent of the monitoring analysis would be to install equipment that measures the usage of your energy in the building. So both fossil fuels, natural gas, propane, what have you, and electricity. And to trend that usage over a course of, say, a year, so that you understand exactly what type of energy and how much energy your facility uses. And that's suggested as a really good first step. The next opportunity here is the Community Building Recommissioning Grant. In this case, they will pay for up to 60% of the eligible costs to a maximum of $55,000. And the recommissioning grant is looking at modifying existing infrastructure in the sense of ensuring that it's operating at peak efficiency or as it was intended to operate. So, you could have an existing control system of some nature that perhaps is outdated or is simply not controlling to reflect your current utilization of that facility. So they would allow for that system to be upgraded or reprogrammed perhaps to ensure that it's operating at peak efficiency. The next opportunity here is this feasibility study in the top right-hand corner. In this case, the grant will pay for up to 80% of the costs to a maximum of $65,000 per facility, or for a portfolio of facilities to a limit of $200,000. The feasibility study is actually where a lot of people are starting this process. The intent of the feasibility study is to review the energy usage of the building as it is today, and then to plan a course of action over the next 20 years, identifying opportunities for infrastructure upgrades that improve the quality of the building, but also reduce energy consumption and reduce the greenhouse gases that are emitted by that facility, directly in line with the mandates set out by the Government of Canada. So a lot of people are choosing to do this feasibility study as their first step. And once you've done that feasibility study, if we go right down to the bottom here, that leads into directly getting funding for these capital projects. So once you've completed the feasibility study, you have everything that the grant issuer would want to see in order to improve these projects. So you may have a list of a dozen, maybe half a dozen projects. They would be validated through the feasibility study, and then it would just be a matter of submitting that feasibility study to the grant issuer for approval of those projects. The one in the middle here that I skipped over, the GHG Impact Retrofit Capital Project funding is more of a one-off. So if you happen to have the resources in place which validate that this one initiative will reduce these carbon footprints by this given amount, you can take that information and submit for funding directly to the grant issuer. A little bit about the GHG reduction targets that are required for each of those funds that I referred to. So the first one being the monitoring and analysis, because that is really just getting an understanding of what your carbon footprint is for that facility. There is no specific GHG reduction criteria required there. It's with this information that you can get to the next step of planning to reduce your carbon footprint. So no criteria required in meeting some sort of GHG reduction target for that one. The next one is this recommissioning projects. Again, there's no specific requirement where you must attain a certain percentage of GHG reduction. They're really looking for energy efficiency opportunities. So if you can reduce your energy efficiency of that building by say 5 to 15%, then that opportunity would likely be approved. Moving on to the feasibility study, which is directly linked to this pathway capital projects. They are looking for, they're looking to attain the targets set by the Government of Canada. So within the first 10 years, they would like to see that you can reduce your carbon footprint by 50%. And within the next 20 years, they would like to see that you can reduce your carbon footprint by 80%. So the feasibility study and the capital projects that it would allow you to apply for, they would expect to see that you can hit those targets. For this GHG impact retrofit opportunity, which is kind of that one-off opportunity, if you can prove that that initiative will reduce your carbon footprint by at least 30%, then you can expect to get that initiative approved. So I'm going to talk a little bit about the feasibility studies now and exactly what they do for you, and what they give the community building as a deliverable. I don't know, some of you may have been aware of this MERS Megawatt Challenge. This was actually done as a validation exercise to say that, if we do these feasibility studies, we can actually attain some of these goals that they're asking us to meet. So there were 9 communities in Canada that participated in this, and Simcoe was partially involved in producing these studies. So the first step here is, as I mentioned earlier, it's really understanding the baseline of the energy facility. So here we have a diagram of a typical ice rink. This could certainly be a curling club. So on the lower right here, we have the refrigeration plant. It's consuming electricity to, produce your refrigeration effect. Generally, that energy or that heat that's taken out of the ice surface is dumped into the atmosphere. Over on the left-hand side, we have the heating systems of that facility. They may be natural gas or propane. Let's assume there's some sort of fossil fuel. So what we want to do is we want to understand how much energy are you using here, how much energy are you using here, how much of this energy is going into the atmosphere, and how much of that energy can actually be brought back into the building so that we can reduce this consumption. So one of the first things that the feasibility study has to do is it has to identify that baseline of your carbon footprint. So in this case, these are actual results from one of these studies that were conducted. This facility had a carbon footprint of 628 tons of CO2 equivalent per year. And what we can see here on the right is that by enacting all of the GHG reduction measures identified in this feasibility study, we were able to reduce that carbon footprint to 74 tons of CO2 equivalent per year, which is a reduction of 88%, which exceeds the requirement, the minimum requirement of 80% GHG reduction. And for all of the 9 facilities that were participating in this, we were able to meet those requirements. So good news there. Some other information that you're going to have presented to you in the feasibility study is some financial analysis. So on the left here, we have this business as usual measures. And really what that means is this is forecasting the operating expense, more or less, of the facility over the next 20 years, understanding what your planned infrastructure costs may be. So the cost of operating the system, but also the cost of maintaining or replacing equipment due to end of life cycle. And it would all be based on like for like. So no measures here that are reducing energy or natural gas consumption or fossil fuel consumption. So in this case, this customer had the dates understood. So they knew that they had to do these equipment infrastructures in these timelines. And this, of course, would be done for each facility. We would work with you to determine what your planned life cycle costs might look like. And from that, we can calculate a net present value, which is the cost, net present value of operating this facility over the next 20 years. In comparison to that, what we would produce is we would produce this list of low carbon measures. So I've only identified 3 of them. There could be many, and not everything is necessarily revolving around the refrigeration plant itself. We would look at the building envelope, insulation, windows, doors. We'd look at initiatives to add solar panels to the building. There's many aspects that were reviewed, and I only showed 3 of them here. The 3 that I did show are all related to recovering waste heat from the facility or from the facility's refrigeration system. And on the right-hand side, here's how each of these impact that carbon footprint baseline. So by these 3 initiatives alone, we were able to reduce the carbon footprint by 50%. And again, that is by recovering waste from the refrigeration plant. In addition, of course, we provide this net present value calculation where you can see that by reducing the energy consumed and recycling the energy consumed at the building, this net present value becomes positive in comparison to the negative value from your business as usual case. What we also do, or what is also done as part of the feasibility study, is to help the community plan these initiatives over time. So you have a list of initiatives and you understand how each of those will reduce your carbon footprint. You also understand the budgetary cost for each of these initiatives. So we would work with you to plan how you would like to implement those over time. So this table here, or this graph, we have dates across the bottom. We have the current situation of what your carbon footprint is across the top here. And then these orange bars are like the goal years. So Government of Canada has asked us to hit those criteria by 2030 and 2050. You can see that this facility chose to hit their 2050 targets by 2036. And of course, how and when you hit these targets, it's a conversation that we have with you, and we develop that budget. So some of the key points of the feasibility study. The main objective is to identify infrastructure upgrades to meet GHG reduction targets set by the Government of Canada. The feasibility study is a one-time application, so it's important to understand that you can include, or the municipality can include, several facilities in this application, but they only can apply for this once. So if your facility is a non-for-profit operating inside of a community, it's important to have that conversation with them to coordinate the application of this. A little bit about the timeline. Generally, there's a pre-application to the funding issuer that takes 3 to 4 weeks. Once that is approved, there's a more detailed application, which takes 2 to 4 months. And once that application is approved, the study can then start. We can generally complete a study in 10 weeks. The next grant that I can talk to you about here is the Green and Inclusive Community Building Fund. This fund is very interesting because it can be used for retrofits as well as new construction. The objectives of this one are to stimulate the economy, create good job opportunities, and to align to the goals of Canada's strengthened climate plan. So that's referring to the GHG reduction measures that I mentioned earlier. In terms of eligibility, again, this is for communities inside of Canada as well as non-for-profits operating therein. They mentioned quite a few different facilities here. Recreational facilities are also mentioned, so I would assume that curling facilities, which are not part of a community center, for example, if they're non-for-profit inside of a community, should be able to qualify for these funds as well. A little bit about the funding structure in this case. So for retrofits under $10 million, they would pay up to 80%. And for retrofits over $10 million, they would pay up to 60%. For new construction projects under 10 million, they would fund 60%. And for new construction over $10 million, they would fund up to 50%. And then if you're in the territories and for Indigenous communities across the board, the potential there is to receive 100% funding for both retrofits and new construction. Part of the feasibility study includes using energy modeling software to validate both your current footprint and your claimed reduction measures. So this fund also specifically requires that. So the interesting thing here is that if you were to do the feasibility study from the first grant, this grant would then, you could reference that same feasibility study potentially to get funding from both sources. So that's a nice opportunity there. A little bit about new construction. So if you do have a new construction opportunity that you're looking at, there are standards to which that new construction must be built to. So the Canadian Green Building Council has guides available, which your architect or consultant could reference. And essentially, in order to qualify for these new construction opportunities, the building needs to be built to net zero carbon or to a net zero carbon ready standard. So again, I would encourage you to speak to your partners involved in this new construction project. They need to review those criteria. So in summary here, the opportunities for recreational facilities to reduce their carbon footprint, we always recommend starting with a natural refrigerant solution. Heat recovery is the biggest opportunity if you have a refrigeration plant. There's a ton of waste heat going into the atmosphere. You need to recover that and put that back into the building so that you not only stop using energy to heat that space, but you can, if you are using a fossil fuel, you can greatly reduce the amount of fossil fuels consuming. There's also an opportunity there for system optimization and recommissioning of many of the different facilities in the building. We can look at the ventilation and HVAC systems. We can review the building enclosure. Again, I'm talking about like insulation of the space, quality of the windows and doors. If you have a building automation system, we want to ensure that that is operating or programmed appropriately and that it reflects usage of the current facility. And then the last one here that I'm touching on is lighting. I mean, if your facility hasn't already upgraded to LED lighting, that's one of the best places to start because they are far more efficient and the cost of that is generally not terrible. So in summary, I'd like to thank you all very much for attending my presentation, and I'm available at any time via email to answer your questions, and we can stop the recording now, and I'd be happy to answer any questions that you might have right now.